believe what is wrong with these projectors. A little bit of housekeeping. We are working on getting the exams graded. It's just taking a while. We want to do it right. So I'm sorry. I'd hoped we would have them done by the weekend. They're not quite done. We do have the vast majority of them done, but we're trying to finish them up. And we'll release the grades for the second half all at once, okay? So hang in there. We will have that out soon. For the second project there, oh yeah, I should start with the lab thing. Those of you who've already been to lab and are freaking out because it's hard, stop freaking out. You have 72 hours for this one, okay? So we extended the window from 24 hours to 72 hours. That's for everybody. So if you have your lab like on Friday, you'll still have 72 hours, okay? Project 2. There are two main requirements for Project 2. One was explicitly in the doc, and the other one we are updating because apparently it wasn't obvious enough. You must use arrays for this project. That is kind of the point of this project, is to use arrays. So, you don't have to use arrays exclusively. You can use other stuff too, but you definitely have to use the arrays, and they have to be the primary data structure you're using for the information. So, otherwise, you can use anything else in Java, except you may not use the automated sorting function built into Java. Everything else you're welcome to use. You must use arrays. Yes?
Is the deadline still to be October 20th?
The deadline has not changed, and we don't currently have any reason why we should, because it seems like most people are making pretty good progress on it. So, and honestly, it should be easier than the blackjack. That's the reality. It should be quite a bit easier. If you're really struggling, you should come and visit office hours and get some help. We'll try to get you moving in the right direction, okay? All right, let's see if these fancy projectors will work now. Yes? Grades for Project 1 we're going to get to right after we finish the exam. We want to get the exam done. As soon as we get that done, we're going to work on Project 1. We're trying to get one done at a time so we can maximize the efficiency and get the results to you faster. Hey guys, I know that this is a super social class, but please be quiet. Yes? You can use hash maps as an auxiliary data structure. You cannot use them as the primary data structure you use for storing the information. Like, you can use them to do some stuff, but you have to use arrays. Like, if you're using both arrays and hash maps, I mean, to be 100% certain, I'd have to see exactly how you're using them, but you're probably fine. Because if you're using arrays as a fundamental piece of the puzzle, then that's all we really care about. That's what we want to make sure you do. So if you have any questions, you can ask me or a TA, and we'll be able to tell you, yeah, that's legit or it's not. But generally speaking, here's what I don't want. I don't want somebody to declare an array and be like, look, I used an array in my project, right? That's what's not okay. If you're genuinely using it as part of the project, that's what we care about. Yes?
For the options, then when it comes to the user, they have to put in some string to be, for example, Delta. Where do you want to put in a new string? You just have to put in a while before that's not included.
Okay, so the question is, what if we want to put in more than one string? So,
if the user wants to put in another string, they have to put in a while before that.
I would have to take a look at the spec because I don't want to give you a bad answer. Can you post that question to Slack and I'll answer it when I look at the spec? What I don't want to do is usually lead you down the wrong path. The question was about entering multiple strings. I believe, based on my memory, that actually it's just one giant block of text, which could include carriage returns and new lines and stuff. And if that's the case, then there's only basically one line. But let me take a look at the spec. If you post it to Slack, I'll try and answer it. But I want to make sure I look at the document we gave you first because I don't want to mislead you. Yes?
Could you post more case trials so we know that our thing is...
Oh, that's an excellent question. The question was, could you post some more case tests and some example output? And absolutely, we can and we will because we just haven't had the opportunity to yet. But yes, we will definitely post some example output. Yes?
Well, last question, like, should we use longs to serve ints? Are you going to do that? You're just going to give us, like, a huge array, like...
So the question was, should you use longs instead of ints? The answer is that I believe that the standard we agreed on was no more than 80 times 25, which is 20 times 100, which is no more than 2,000 characters. So you should be fine. Yes?
If we are sorting it by frequency and have a conflict, both characters appear 7 times, should we sort them alphabetically according to ASCII or sort them by which one appears first?
Okay, the question was, if we have more than one character that has the same frequency, how are we supposed to arrange those? And actually, the TAs are rewriting the spec for that part right now to make it more clear. So hold tight, and that answer will be available shortly. All right, so I think that covers the big pieces of the puzzle. I'm going to do a quick review because I know some of you were scarred by last week and forgotten everything. No, not so much? Maybe? Yes, okay, yes, I have confirmation. Okay, I hope you're not too disheartened. It was the first exam. I would encourage you not to read too much into that. I mean, if obviously you gotta rate that for yourself to some degree. But I will tell you that historically people do better on the second one. That's just history when I've been teaching. It doesn't mean that'll be true in this class, but it gives you some kind of indication. All right, as a quick review, we started talking about arrays last time. And an array is a type of container, and some of you have already started using other containers in your project, which I'm really excited about. I just want to make sure that you learn arrays really well. The other containers are like linked lists and array lists and hash maps and stuff like that. So a lot of the stuff we're going to be talking about that applies to arrays also applies to other types of containers. Now, you don't need to know any of the other containers until we get to them. I'm just explaining that because some people are already using them and I want them to have some time. So a container just holds stuff. So the example we looked at last time was an array, which is a type of container that has a bunch of the same type, one after another, right? This is a string array that we looked at last time. We also talked about how arrays are a reference type. And this is true for anything except for the primitives. The primitive types are like integers and floats and characters and Boolean variables. Everything else is a reference type. One thing we haven't covered yet is what we call enumerations. And an enumeration is a set, sometimes we have a set of values we want to be able to assign something, but they aren't really numbers. But they're different from one another. They're distinct. They're discrete. And we might want to have some way to represent those. So let's say we wanted to represent the days of the week. We could represent these with numbers, right? You could do like 0 through 6 or something like that. But then you'd have to always remember what the value was and stuff like that. An easier way to do it is to use an enumeration. An enumeration lets us give names to a bunch of different values, and then the computer will do all the work behind the scenes to assign numbers and values to them. We just have to keep track of the identifiers. So in this case, I have Sunday, Monday, Tuesday, Wednesday, Thursday, Friday. Those are my weekdays. So this is an enumeration of weekdays. Then, if I want to use a variable that has that enumeration type, I just say whatever the type is, so in this case, weekday, and then I give the variable a name, day, in this case, right? So I can name it whatever. I can name it Jimmy Dean or whatever, right? And then I give it the value. In this case, I'm going to give it the value of weekday.Sunday. So this means in the weekday enumeration, it's going to have the value of Sunday. Any questions up to this point?
Yeah.
Go ahead.
I didn't get any of that.
You didn't get any of that. Okay, so you get the idea that these are all distinct values.
Yeah.
So they're all unique, right? We're saying we need a way to keep track of days of the week. So I'm going to give all the names of the days of the week, and that's the enumeration. And then I'm going to create a variable that's going to hold one of those days in this case. So this day I'm going to say, currently my day is Sunday.
Okay. Oh,
yes.
Gotcha. Yeah.
Would it hold Sunday as a string?
Oh, that's a good question. The question was, how does this actually store it in memory? I changed your question a little bit. And the answer is that behind the scenes, it actually stores it as a number. So what it does is the compiler creates a number and associates it with a value, but it's not something you actually have to worry about. It keeps track of that behind the scenes. Does that answer your question? So usually what will happen is when you create an enumeration, behind the scenes what the computer will do is it'll start at 0 and count up. So probably what the compiler is doing is turning Sunday into a 0, Monday into 1, Tuesday into 2, Wednesday into 3, Thursday into 4. Oh, I skipped one somewhere. I'm missing Saturday. Yeah, so apparently I don't even know the days of the week. I need to learn that preschool song again. Yes?
Why is it weekday day equals weekday dot Sunday? What is weekday in like the first part?
Good question. So the question was, what is weekday here? This is the variable type. So here I'm saying I'm going to create a new variable of type weekday. Just like I can create a variable of type string or type integer. This time the type is weekday.
What if you said the string? What if you said
If I said
Called
string day,
yeah.
then it would not compile because I'm using a weekday enumeration type. Basically what I'm saying is I'm going to create a new variable type, and these are the only values it can hold.
Oh, okay.
Sorry, maybe that was a more clear way to explain it, but does that make
makes
sense?
Yeah.
Okay. Yes.
Could you reference something within the enumeration by its location, like get Sunday with 0?
Oh, that's a good question. The question was, can we get a value in the enumeration by location? As far as I know, in Java you cannot. In other languages there are ways to do it, but in Java I do not believe that is possible. I'll double check it, but I don't think so. Yes.
What do you mean by when you say you're going to make a weekday type?
Okay, the question was, what do I mean when I say I'm going to make a weekday type? Basically, I'm creating a new variable type. Just like we have, like here's another example. We have a Boolean variable. It can only have two values, true and false, right? Here I'm making a new variable type, weekday. And weekday has only, well in this case, because I can't count, it has 6 different possible values. It should have 7, right, because I should have Saturday in there. But basically it's saying I'm creating this new variable type, and here's the values it can hold. Does that, I don't remember who that was. Does that answer your question? Okay. Yes?
Okay, maybe I'm missing something, but like doesn't day, like weekday day and log have to be declared?
Doesn't weekday day, what's that?
Doesn't the day part have to be like a string declared somewhere?
No, it doesn't have to be, these are actually type values, so they're like identifiers, they're not strings.
Okay.
Does that clear it up for you? Yes?
If you're going to print out day, would it print with a string variable?
Oh, that's a fantastic question. If I printed out the day of the week, what would it print? And the answer is actually I don't know. I would have to test it. So that's a good. We should, if we have time at the end of the lecture, I will test it. Okay, that's an excellent question. Man, it's always one that stumps me. Anybody else? Yes.
Why do you declare it outside of Maine?
Oh, good question. Why am I declaring it outside of Maine? That's a fantastic question. The answer to this one is that I can't declare this inside of Maine. That's why. Enumerations cannot be inside of a function. They have to be at the class scope, which means they have to be outside of the methods. Does that answer your question? Yes.
What is line 7
What is line 7
doing?
doing? Okay, that's a good question. Okay, we're getting there. So, line 7, this says, I'm going to create a new variable. The type is weekday. The variable name is day. And then I'm going to give it the value, Sunday. So, just like I could do a Boolean, I'm trying to think of it here. Boolean foo equals true. It's the same thing here. I'm doing weekday day equals Sunday. Does that answer your question?
Yeah.
Okay. And I thought I saw that. Yes?
So if it's not a string, what can you do with the enumeration?
The question is, if it's not a string, what can you do with an enumeration? And an enumeration is totally a logical construct. So, in some cases, there are cases where you just need some way to represent something efficiently, right? You could use a string to do the same thing. The problem with strings is that they are not as efficient. They eat up more memory, for example. What's going to happen if you have a string is it's going to keep it as a string when you actually compile it. In enumeration, the compiler turns into just a number. And numbers take up almost no space by comparison. So they're way more efficient, they're quicker, and you can do rapid operations with them. Does that answer your question? Yes?
Can you add things to weekday, or can it only be within
Oh, that's a really good question. The question is, can you add things to weekday? You mean can I add it to the enumeration later?
Yeah.
Later on, you can't add anything to it in Java. So different languages are different, but in Java you can't add things later. But there are languages where you can. Does that answer your question?
Yeah.
Yes.
So if you were like writing some program routine of this for like the next day, would you then put the brackets where Sunday is, and put like an index of like 0 to represent Sunday, and then loop 1 for like Monday?
The question was, if I wanted to go on to the next day, could I just increment it or something like that? I'm going to have to double check that, but I don't think you can in Java. In C and C++, we often do that. We do exactly that. But in Java is a little bit more limited in what their enumerations can do. But we can, I'll double check it, but I'm pretty sure you cannot do that. All right, so let's take a look at what we might actually do with this. This is just a really simple example here because I want to demonstrate how these variables work. And, obviously I know what the result is going to be here. But what I can do is, once I have some variable with some enumeration value, I can test that enumeration value. So I can say, if day is Sunday or if day is Saturday, which doesn't exist because this would actually be a compile error, but ignore that for the moment. I need to add Saturday up here. Then we're going to print out, I'm so glad it's the weekend. And otherwise, we're going to print out, I hate working. Okay, does that make sense to everybody other than my ridiculous compile error? Which I will fix. Okay,
It's not
so, what's that?
It's not really an error. Saturdays never really happen.
Saturdays never really happen? Yeah, I guess you could say that. I do feel like it's my second Friday usually. So, okay. So, I want to talk to you a little bit about default values. We have these array types, and we can have arrays of all kinds of different things. But there's an important distinction to be made between arrays of primitive types and arrays of reference types. Yes?
From the previous stuff, how would we ever use that?
How would you ever use that? This is a pretty good example if you're trying to keep track of the day of the week, but you don't have to use it ever. You can always represent things with numbers instead of this. It's just a way to make it a little bit easier to track. That's really the only function it is.
Okay.
There's an important distinction to be made between primitive and reference type arrays. So when we talk about the primitive types, we're talking about integers, floating point types, booleans, and characters. On the other hand, strings are a reference type. The reason this becomes important is because they all have different default values. So if I create an array, but I don't put anything in it right away, it's going to have some default value. Int, float, and boolean all have specific default values. And then for references, there is yet another. So in the case of an integer, the default value is 0. In the case of a float, the default value is 0.0. In the case of a true-false value, a Boolean value, the default is false. And then there's strings and other reference types, and they have what we call a null reference. Have you guys ever heard of null before? Null references? You may have even seen it in some of your errors, like null pointer reference or something like that. A null, in computer science and languages specifically, a null pointer just means a pointer that doesn't point to anything. It means we've assigned it a value saying this is not a valid entry. That's all it means. It's kind of like undefined, but a defined undefined, I guess you could say. Yes?
When you're using arrays and you don't want to define a value yet, and you just want to add user input values, would you declare the array null for temporarily?
You could. The question was, if you don't care about what the values are initially and you just want to assign the values later, could we just assign it to null? With arrays, it's going to default to null. It's going to be null always. Like when you first create it, it'll be null. It'll be filled with null values. Now, for reference types, like let's say you created a string type, if you didn't want to assign it to anything to start, you definitely could assign it a null value to start. Right? And null just means a reference doesn't point to anything in particular. Does that make sense? All right, anyone else? So, I wanted to show you this when we're talking about arrays because you're most likely to run into it starting out. But null values for references are very commonly used. Anytime we have a type that's supposed to point to something, right, that's supposed to hold a memory address, anytime we have that and we don't have anything to point to yet, we should always try to point it to null to start, because that way we have we know that it's not a valid entry. We don't accidentally get a garbage value in there instead. Now, in Java, there's a lot of protections around the language to prevent you from having a garbage value. But when you get to C++ next term, C++ will totally let you put a garbage value in a pointer. It'll be like, do whatever you want. You can destroy everything if you want to. Like I said, C++ is like a sawed-off shotgun. It can do great work in the right hands, and it can also let you blow your foot off. So that's a pretty accurate assessment of the language. So just keep that in mind. Anybody have any questions about array default values or any of the stuff we've covered up to this point? All right, so let's say that we wanted to go through an array, one entry at a time, and we wanted to use a loop. Well, we've seen loops before. We've seen a while loop. We're going to take a look at how we can actually go through an array by counting up. So what we need to do is we need to have some index variable, which we're going to call counter in this case. And while that counter is less than the length of the array, we're going to keep looping. So .length is a special attribute that exists in all array types. Anytime you create an array, you can always check its length by accessing the length with .length. So potato.length, how many elements does potato have in it?
4.
Has 4. So potato.length is going to be 4. So while the counter is less than 4, when it's 0, 1, 2, or 3, we're going to keep going. So the first thing I'm doing, did I already do this example with you? I'm having deja vu.
I don't think so. Me?
Oh, that's a good question. The question was, shouldn't it be less than or equal to?
No.
The answer in this case is no. Right, because we start counting at 0. Right, because if we went to 4, we'd have 0, 1, 2, 3, 4, and 4 is actually past the end of the array. It's a good question. Thank you. So, I feel like I haven't shown this one. I don't know. So, or maybe I showed you something similar. Yeah. Okay. So anyway, so I did show you this already. So this is the fixed version, right? So I talked to you about it last time, and I had a mistake in it. But this will actually go through the array. Okay, so this was a review slide. Let's go to the next one. Whenever we pass arrays into functions or methods in Java, it's important to remember that it is a reference type. And the reason this is important is because reference types and primitives are going to act differently when you pass them. Oh, sorry. Here, this is. Here, let me skip forward to what I was talking about. I'll come back to this. Right, when you pass them in, they're going to act differently if they are reference types than if they are primitive types. So let's say that we have this class. This is a variation on something we looked at before. We have this say hello method. It takes in an array of strings. And down here we have a string name, which has bat and man in it. And we say hello name. Up here, when we get the names, we are going to set names 0 to equal to itself plus names 1. So let's see what actually happens here. So we execute main, and here's the stack. So we're going back to this. We're going to start using this model more often. So we have this stack, and it's got the arguments on it. What else is going to go on the stack?
Say hello.
What's that?
Say hello. Say hello function?
We are going to have a say hello stack frame, but inside of main, what else is going to go on the stack? Right, so name, the string array name, is going to go on there. So, and then we're going to point that array to a value, which is, we're going to point that array reference to a value, and this is the first time we've seen something else called the heap. And the heap is where all new memory variables are stored. Anytime we create a reference type, the value of that reference type is going to go on the heap. These are two different sections of memory. And in a computer, the way it works is the heap goes up from one end and the stack comes down from the other. So you're basically moving toward the center. And eventually you can run out of memory, right? So you can run out of stack memory, you can run out of heap memory, but basically they grow toward each other over time. So that's basically how the memory works. So we have this stack, and then name is going to create this new variable on the heap, which is going to hold two values. And inside those each are actually references themselves that point to two different strings. One points to that, and the other points to man. So I want to make sure everybody follows this before I move on. Does anybody have any questions about the setup so far?
So heap just holds holds the array, the variables of the array.
Yes, the heap holds the variables of the array, yes. And any other type of reference data.
Okay.
So the references themselves can be in the stack or in the heap, but what the references point to are always on the heap in Java. And in other languages, there's some ways to blur the lines, but that's the general trend. Does that answer your question? Anyone? Yes, in the blue. Line 12, let's see. Okay, so line 12 is us calling the function say hello. Does that make sense? I lost track. Does that make sense, or are you? Yeah. Okay. Yes.
What?
Oh, that's a good question. The question was, isn't there supposed to be a return value for say hello? Not for this one. Does anybody know why I don't have to have a return for say hello here? Yes.
Void?
What's that? It's true. It does print within the method. That's part of the puzzle. There's one more thing that has to do with
Calling it.
Maybe it has to do more.
Oh, close. You said we're calling it a name. Wait. Somebody said it.
Say hello takes an
No, you said yes.
Yeah.
It's because it's a void type. Void means it doesn't have to return. It doesn't return anything. So if this was int, it would have to return an integer type. Let's see. I don't remember. You asked that question, right? Does that answer your question? Yes. Go ahead.
On line 3, why did you call string names instead of name?
The question is, on line 3, why did I call this names instead of name? Well, I intentionally changed the identifier to show you that they're not the same one. I could have called this my names or something like that. I just wanted to distinguish between the two. That's why I gave them different names, because they're not the same variable. But there's nothing special about those names. Yes, go ahead.
Why in line 5 is there quotation marks in between the name 0 and the names 1?
The question is right here, why is there quotation marks? And the answer is, I'm just putting two strings together. We're actually going to go to this line in just a second and see exactly what's executing. So hold on to that thought, and we're going to see exactly how this plays out. Anyone else have any questions about the general setup here before we actually pace through the rest of the code? Yes? Yes. So name is a reference, which is a pointer, that is a reference that points to an array which has pointers to strings. Yes. So it is a little convoluted, but this is the type of stuff that's important to understand. That's why I'm bringing it up now. All right. Anybody have any issues? I want to address them now if I can. Can I repeat the thing I just said? Yes. The thing I just said is name. Name is an array type, right? All array types are references. So a reference is like an arrow. It's like a pointer. So name is a reference, right? It references an array. This array is an array of references. So each one of these is a pointer to a string. Does that clear it for you? Okay. So it is a little convoluted because we have arrows going to arrows, but we're getting further down the rabbit hole now. Yes?
Since arrays are reference objects, but unlike strings are mutable, you can like concatenate them with other things as well.
Yes, we're actually going to take a look at that example in just a second. So the question was, because arrays are mutable, we can change things and we can concatenate them, right? And the answer is yes, sort of, in some circumstances. We can definitely change them. Concatenation is a tricky thing, but we're going to take a look at an example right now. So let's take a look at how this code works. So then we call the function say hello, and that's going to jump up to this line. And then we're going to add a new part to the stack for say hello. And what's going to go on say hello? What's going to go on say hello's stack frame?
Names.
Names, right? This variable right here that came in called names. And now keep in mind, we passed in name here, so whatever name pointed to, names is also going to point to. Now this is a really important distinction that is very important, so listen closely. Whenever you call a function, whenever you call a method, what it does is it makes a copy of whatever value you pass in. So, say hello makes a copy of name, the reference, the pointer, the memory address. It makes a copy and it stores it in names. The reason these both point to this array is because they both hold the same memory address. That is, they point to the same thing, but they are different pointers to the same thing. Yes?
Why is it called names instead of name?
I was just using a different name, a different identifier. They're not the same variable, that's why I used a different. That's the only reason that there's an S on one and not on the other. Yes?
But since you're passing the address, can't you change the actual variable?
Oh, that's an excellent question. Since I'm passing the address, can't I change the actual variable? And the answer is yes. I'm not changing the variable itself, but I am going to change what it points to. That's exactly what we're going to do right now. And that's why I'm making such a big fuss about this. Is because it's like if I pass an integer in, it's just going to make a copy, and if I change the copy, it won't change the original. But because I'm using a memory address, if I change what it points to, the other thing still points to it. Make sense? Okay. Okay, so let's take a look at what happens here. So, we call say hello, and then we execute this operation, which is the first thing we do is we're going to take these two strings, we're going to put a space between them, and we're going to concatenate them, which is going to create a new string, Batman. So that's what this operation does. We do name 0 plus the space plus names 1. That creates this new string called Batman. And then we change this pointer, name 0, this one right here, to point to Batman. Does anybody see a problem?
Yep.
Yeah, I'm not pointing to the first name anymore, right? Basically, I just lost this information. Now, Java's smart, so when you do that, Java is going to figure out that you did it, and it's going to clean that up. It's going to say, oh, look, memories nobody's using. I'm going to erase it. And that's exactly what happens, is the first name would get erased in this case. And then, this line says, okay, print out the name. We might expect that to work fine. But the problem is when we go back, now that variable has been changed. We've modified the array. So even though it made a copy of the memory address, it did not make a copy of what we pointed to. This is a really important distinction. You have to understand the difference. In primitive types, we copy the value. In reference types, we're copying a pointer, a memory address. Yes? Oh, why did that go away? So here, I'm going to step back to make sure that this is clear. So before we were pointing it back, right? That's basically, this is names 0, and this is names 1. You follow that so far? So, right here, we're reassigning name 0 to point to a new string. So we're not pointing to it anymore. Once we do that, we don't have any way to get back to that memory, and Java is going to clean it up. Does that answer your question? All right, anyone else? All right, I know this. Oh, yeah, go ahead.
I'm a little confused. Isn't name 0 redefined in the scope of say hello?
That's a good question. So the question is, isn't names 0 defined in the scope of say hello? Names is defined in the scope of say hello. Remember, names, all array types are pointers. So names and name point to the same thing. So when we change names 0, we're also changing this other one. So basically, because we're pointing to the same object, like we made a copy of the reference, we made a copy of the memory address, but we didn't copy the object itself. We didn't copy what the memory address points to. Are you still confused? You think you're okay? You want to chew on it, or? Okay, we'll keep going. But if you continue to struggle when we take a break, come up and I'll try to work out for you, okay? All right, anyone else? Okay, so when we get back here, you may see, What is it going to print out when we print out this line? It's going to print out Batman Man. Yes. Because now we've accidentally destroyed our original variable. Okay. So, and as we go, by the way, as we go back up the stack, here I should point this out, as we come back from methods, the stack for that method gets erased, right? So that original reference names gets deleted and we're just left with name. And then after the whole function completes, the original stack frame disappears too. And then finally, at the very end, when everything shuts down, only then does Java clean up the rest of the heap. Okay. Yes.
So if we want our array to stay safe and not be able to be touched by any other code, we need to create a new array and copy the values over.
Yes, I'm going to rephrase your question and repeat it. So the question was, so if I don't want a method or other code to be able to modify my array, does that mean I have to make a copy of it before I send it in? And the answer is yes, that is exactly what it means. It's what we call a deep copy operation. A shallow copy is just copying the memory address, the reference itself. A deep copy means actually copying all the values and creating a brand new structure. It's a frustrating point for many folks, and understandably so. There are some Java methods that help with this, like all objects by default have a .clone operation, built in, and they will copy everything on the current level. But in order to copy everything, you might have to go down to the deeper levels and clone every sub-object as well. Yes?
Will that mean that since they're not pointing to the same thing, it can't be used, like, if you change one array, the other one's just going to stay the same, and since you're using different like functions?
Yeah, so I'm going to rephrase your question, but you're absolutely correct. So the gentleman here said, doesn't that mean that if we make a copy, then they're pointing to different things, so if we change one inside of a function, it won't change it? And that is also correct. So if you want to be able to change the data, you don't want to make a copy of the whole array. You just want to copy the reference. If you do want to be able to change the data. If you don't want to be able to change the data, then you have to make a whole copy of everything and pass it. Does that answer your question? Okay. So those are the two different approaches based on what you want to do. Yes?
So just to be clear, so make a copy, you just make a new variable, and it's like equal to, like make a new array, and then use the array.
That's an excellent question, and you're not correct, but I want to explain why. I'm glad you asked. I'm glad you asked, because it's a point of misunderstanding. So the question was, so I can just create a new variable array and just set it equal? And the answer is no, that's what you can't do. You have to go through every index of the array and set every index value equal to the other one. That's the only way to copy the array. Does that answer your question? Yeah, exactly. You have to have a loop, and you have to go through, and you have to reassign everything. Yeah. Okay, so I know all this array stuff sounds like kind of like a bummer, right? But on the plus side, we have some stuff. This is the slide I skipped over. We have some stuff that can actually help us with arrays, and that's java.util.arrays. And it has a whole bunch of array functions that can help you when you're working with arrays. For example, there's a copy of function that's really convenient if you want to make a copy of an array. What it will do is it will do just what we just talked about. It'll create a new array, and then it will copy every index using a loop into that new array. So that's really useful. There's also equal, .equal, and then what that will do is it will go through and it will compare every element to every other element to see if these are actually equal to one another. .fill will let you fill up an array with a certain value. Sort will let you sort some stuff, which you can't use in Project 2, by the way, in case you were wondering. You're not allowed to use that function. It's the only thing we're saying you absolutely cannot use. That's the only thing. And then there's binary search, which actually lets you search through. If you see T here, you probably see this T, right? That just stands for type. That means it can be any type. You can have any type of array, and all these functions will still work no matter what the type is. It could be an int array, it could be a string array, it could be a Bob's your uncle array. It could be any of those things. Yes?
What is the if sorted for the binary search mean?
Let's see, it says return, if sorted. That means you have to be working on an array that's already been sorted from it's either greatest to least or least to greatest. I have to double check. But you have to have a sorted array before you can do a binary search. Binary search requires an array that's already been sorted. So, which we are going to get into more probably later in this class if we have time. But does that answer your question for now? Yeah. Yes, go ahead.
Does the
The question was, does the fill fill method change every value in the array to that value? And the answer is yes, that is exactly what it does. Anyone else? Okay, so hopefully you can find a use for these. Like I said, I'm not going to make you memorize these, right? But, they are available for you to use. Now, a lot of times after this we'll take a break. A lot of times in computer science, we're going to need more than one dimension to our arrays. We might need a two-dimensional array. So like, for example, a lot of board games, they use 2D arrays. So like chess is 8 by 8, right? Tic-tac-toe is 3 by 3. So let's say that we wanted to represent a tic-tac-toe board. We might use an enumeration with just the values x and 0. And inside of our enumeration, inside of our main, we might create a tic-tac-toe board. So we have an array of tic-tac-toe values board, and we're going to create it so that it looks like this. So initially, it has null values. Remember that null concept? It has null values for most of the spaces, but we're going to create a board where O has already gone in the middle and X has gone down here in the corner. Yes?
I think you missed the brackets. It should have 3.
Let's see. Did I miss a bracket?
Tic-tac-toe should have 3.
No. It's a 3 by 3, so there's 2 axes. That's why it has 2 sets of brackets.
The 3 by 3?
So if this is a 2-dimensional structure, that's why it has 2 brackets.
That's right, true.
Does that make sense?
Yeah.
If it was a 3-dimensional thing, then it would have 3. But I do want to make that clear. Here what we're saying is we have 3 across and 3 down, so that's 2 different dimensions. And that's why we have 2 different sets of brackets for this array reference. Yes? How much memory does it take for, what was that? Oh, how much memory does it take for an enum? Every enum value defaults to an integer size. So the default is integer. I don't think you'll have to need more than 4 billion possible values for enumerations. Yeah, it's integer in size, which is very reasonable for modern CPUs. Yes? Oh, that's a good question. The question is, if I have a multi-dimensional array, is that an array that references other arrays? And the answer is yes, that is exactly what it is. It's an array that has a reference to an array that has a reference to values that may themselves be references. This reference is all the way down. Yes? The question is, which one's the row and which one is the column? I always get these confused, to be perfectly honest. And the answer is that the outer index is the, basically what we're saying is tic-tac-toe array. So the outermost index is going to be in this setup, the way that this is set up, the outermost index should be the rows. Okay? And I definitely am not going to test you on that. The most important thing is to be consistent. Whatever axis you use it consistent. Yes? RC Cola? What am I missing? Oh, yeah. Row column, RC Cola. Oh, that's good. That's a good mnemonic device. Oh, I like that. Thank you. All right. Anyone else? Okay. So, this is just one example. Another way that I could do this is I could actually explicitly say this is going to be a 3 by 3. And then I could go through and I could assign values, right? So, remember, by default, arrays are going to have null values. And enumerations are reference types, just like strings and other types of objects. So they're going to default to null, and so if I know that that's the case, I only really have to assign 2 of the values. Yes?
So instead of like all
Yeah, instead of all this stuff, I could just have these 2 lines. I'm just showing you 2 different ways you can do it. Make sense? And sometimes one's going to make more sense than the other, right? In this case, probably the bottom one makes more sense. But that's not universal. Okay, we did this, so yeah, let's go ahead and take a break. Please be back at 4 o'clock and we'll get started again.